Let's use this simple example to talk about parametric design within Rhino. In previous videos, we talked about measure surfaces and how we can add a fillet edge to some of these surfaces. And if we want to have a greater level of control, we can also use a blend curve between some of the surfaces. We can adjust where we trim the surfaces, and we can build curvature continuous transitional surfaces instead of filleted surfaces. And one of the questions I often get is, why do we have to spend so much more time to go from the model on the left, which is simple fillets, compared to the one on the right, which is more complicated transitional surfaces, and they look very similar to fillets. And so I will answer that in this video as well. But in this video I wanted to mainly focus on some of the advantages and some of the disadvantages of parametric design, specifically using Grasshopper. But first, let's talk about some of the tools that come by default in Rhino, such as the record history tool, before we jump into Grasshopper, because Grasshopper works a little bit differently. So here I have the record history with the always record history on, so it is enabled. And we will talk about using a blend curve and some of the disadvantages that this has compared to parametric design. So this curve here is curvature applied, curvature continuous to both this surface on the top and the front surface. So now if I do a sweep, and with a sweep to curve, we can select the bottom and top rail and then the cross sections. And here we have the option to keep this transitional surface curvature implied to the top and bottom. And the advantage of using the record history tool is that you can take this surface and you can move it down. And if you move it down, the transitional surface will adjust. And if I move it back, the transitional surface will adjust as well. And one thing you will notice is that the curve, the blend curve that we used, it did not adjust according to the change in the surfaces. So it cannot do that using record history. So this is one of the limitations that record history has. So if we wanted to make a change that would dictate that some of these control points should adjust, record history will not be able to understand where these points should be, at least not by default. Now, another thing that you often would want to do with record history that you cannot is to adjust where the surface is. So for example, from a front view, if I undo what I have done here, from a front view, if I wanted to adjust where this edge is, and if I wanted to move it down, it's essentially an offsetted curve from the outside edge. So I should be able to just offset the curve, change the distance of the offset, and it should be able to allow me to have this transitional surface become larger and larger and larger. But if you did that, you would have to have record history both for the surface being trimmed, for the blend curve, which, as we saw before, it doesn't really self-adjust, and the surface would have to adjust as well. So that's another constraint when using record history, that you cannot do that. You cannot have a blend curve, you cannot not have a trimmed edge, and then have the surface adjust every time you make a change. So to do that, you would use Grasshopper. So now let's talk about Grasshopper and some of the advantages that Grasshopper has over using record history, and we can also talk about some of the disadvantages. So I will just type in Grasshopper, but you can also click here on this button. It will get you to the same place. And for the sake of this demo, I have already created a definition, and I have started to make changes just to better communicate how you can use Grasshopper to achieve some of the things you wouldn't be able to achieve with record history. So I'm not going to go too in detail on how you would create this definition, but I will show you some of the advantages. So here you have something that looks very similar. You have a fillet edge that has been defined with this constraint. And the constraint is, we call that a variable. The variable is set to 1.5, but you can change it. That's why it's called a variable, right? It can vary. You can change what it is. And now you can see it's updating. It's becoming larger. We can make it smaller. And we can change this fillet independently of the other one. Now, one of the great advantages within this Grasshopper interface, you can select an input, so a variable like this one, and you can make it the same input. So for example, if you wanted both edges to be the same size, you can see how now I'm making both of these fillet edges approximately the same size. Now, one thing to keep in mind is the way I have created this definition. I'm using a type of blend curve, and I'm creating a transitional surface that looks relatively smooth. It's not curvature continuous, but it looks almost as if it is perfectly smooth. I believe it is tangent, so it's relatively smooth, but it's not curvature continuous. And I'm doing a little bit of cheating to be able to get that type of surface. But we can talk about this a little later. For now, the concept I want you to understand is this idea of when you create a parametric design, you have a lot more control, even more control than using something like record history. And it's a lot more dynamic as well. And so you could see some of the advantages of using such a tool. For example, if you're working with an engineer and you are being told that the fillet has to be a very specific size, and you would have to make some major modification to your entire model to be able to make that change, but using Grasshopper, you can simply change this variable, this input, to whichever size is required. Now, another advantage here is the way I have it set up right now. I could make a modification to a surface. So at this time, I have this surface here for the top. And the way that the definition works is I'm extending the surface, just like we would do in Rhino, doing a surface extend. I'm extending the surface back. I'm able to define exactly where I want that surface to be. But if I take that surface and I switch it with a different surface, like this one, you can see this surface here has curvature. The parametric definition will allow this surface to be extended back to the same defined definition, and it will allow me to make that change very easily. Now you can imagine if I was doing that by hand, I would have to essentially delete all of the side surfaces and replace them with this new surface just to be able to go back and redo all of the transitions. But now, using a parametric design, I can simply connect the new surface to replace the old one, and you can see the whole model self-adjusts. And I still have the same ability to modify the fillet. So I can make it very small, very large. So you can see how this could be very powerful if you're talking to an engineer and they said, well, you do not have draft to this one surface, we have to change that surface. And as you saw, within a few clicks, I was able to replace the initial surface with a new one, which actually has the draft that we're looking for. So we could make this part a lot easier than if it was the original surface, which is relatively straight. So I think this gives you a good idea of some of the advantages that this definition could give you if this was the intention to work with engineers to mass produce a part. Now, one of the big disadvantages of this is as you're creating a definition such as this one, if this is for a quick mock-up and you already know what transition you're using, you already have a design, you've already done your sketches, and everyone signed off on them and they know what it's supposed to look like, well, this may take a long time because creating such a complex parametric design does take a little while, and this is not as complex as some of the other definitions that I have worked on, but you can see it does take a lot of work. You have a lot of components. And in Rhino, by default, the way you create a transition is you simply select an edge. Now, within a parametric design, you're going to have to define which edge you're using, and you may want to automate the process. So you may have to say, out of the entire surface, look at each of the edge. So now you have two components to say that. You have a surface and a way to look at the edge. And then you're looking at the edge as a curve, and then you have to check the distance between each of the curves. So just to select an edge, you're going to need many components, and you're going to need to understand how to create a logic that allows you to automatically select them. Otherwise, you're going to have to do this process manually. So this can be very time consuming. I'm going a little bit in depth as of how you would create the components, but the point is sometimes it takes a lot more time to create a parametric definition than it does to simply create a transitional surface. So it depends on the purpose of your model, and it depends on your work environment, if you're working with engineers or with a designer, or if you're working by yourself. Now, another advantage too is within Grasshopper you can set up some definitions such as materials. So in this case I was able to find a way to create reflective materials. You can see there is a little bit of an issue here with the front. I'm guessing it's because of the transition. Yeah, it must be because of this transition here. Yeah, so you can see here we're getting slightly better results. For some reason, when I used the original surface, I could see there was a little bit of a kink here. So that's interesting. I had not noticed this detail here in the middle of the surface. So you can set up your workflows, as you can see here, having the material being able to change from something that looks matte to something that looks really soft, and something that looks really reflective. And that can be really useful to show your design as a finished product, or just check for reflections to see if there's any kind of bumpiness, if your transitions are not being as continuous as you would want them to be. And it can also allow you to kind of check on the aesthetics, whether you want a sharp fillet or a sharp transition, or something really soft. So I hope this gives you a good sense on the advantages and some of the disadvantages of using parametric design within Rhino, specifically using Grasshopper as a tool.